In this video, we're going to talk about gravitational potential energy. Now, gravitational potential energy is one of many forms of energy, and energy is one of the most important concepts in science. And energy will take on many different forms, and these are just a few of those forms that it may take on, like mechanical energy, nuclear energy, chemical energy, and electric magnetic energy. Although the amount of energy in the universe is constant, one type of energy can transform into another type of energy. Now, potential energy is a type of energy that's associated with the position of an object, and there's different kinds of potential energy. These are a couple of examples here that we can look at. Now, we might have potential energy stored up in a coiled spring, or potential energy stored up in a chemical bond. And this is potential to do something. So it's kind of this energy that's in waiting that is going to go out and do something. In our case, we're going to focus on gravitational potential energy. So what exactly are we going to learn in this video? Well, first we're going to define gravitational potential energy, then we'll learn the equation to calculate gravitational potential energy, and then finally we'll solve a couple problems so that we can now learn how to use that equation. Now, when we discuss gravitational potential energy, we're investigating objects in a system that includes the Earth, and all objects are going to be attracted to the Earth. Now, since the Earth is the largest object in our system, all objects are going to accelerate towards the Earth at a constant acceleration due to gravity, and that constant is 9.81 meters per second squared. And you may have already known that, but this is our constant acceleration due to gravity. Any object that's lifted to a higher height is going to gain potential energy to move back down towards its resting surface. Now, the higher the object is lifted, the more gravitational potential energy it's going to have. And the surface doesn't have to be the ground. You can see in our example here, this book is lifted above the desk and it'll fall back onto the desk. And if we lifted it, say, 1 meter off the desk, it would have the opportunity or the potential to fall back 1 meter onto the desk. And if we moved it horizontally here now, it's going to fall all the way to the ground. And so you can see that it's got a little bit more potential because there's greater height there. So the reference matters on where it's going to end up falling to. Now let's look at the equation so we can learn how to calculate gravitational energy. We've already seen that height matters, and we can use the symbol h to describe height. Some people may also use the symbol y or delta y, because if we're talking in the up-down direction, y would be a good variable to describe that up-down direction. The other thing that matters is g, and g means the acceleration due to gravity, which is 9.81 meters per second squared, just like we learned previously. And then the other variable that matters is the mass of the object. And the greater the mass an object has, the greater its potential energy is going to be. And this, all of this stuff here, multiplied together, is going to give us the gravitational potential energy. And so this is our equation that we can use to calculate the gravitational potential energy. So let's try using this equation to solve a couple of problems. So here's the first one we'll try solving. It says calculate the gravitational potential energy of a 75 kilogram skier that's at the top of a 15-meter drop. First thing I'm going to do is I'm going to put in the equation that I'm going to use to solve the problem. And this is the one we just learned. So GPE, gravitational potential energy, is equal to mass times gravity times height. We're given the mass of the skier, which is 75 kilograms. We know g, which is 9.81 meters per second squared. And we're given the height of 15 meters. And we can plug all of that into our calculator, and we'll end up with 11,036.25 joules. So since this is an energy, our answers are always going to end up in joules. Now you can see this is a pretty big number, and we have way too many digits here. we're going to get a lot of big numbers when we calculate gravitational potential energy. So what we want to get used to doing is converting this into kilojoules, using kilojoules instead of joules. And a kilojoule is equal to 1,000 joules. And so instead of writing this answer in joules, I'm going to divide it by 1,000 because that's going to convert it into kilojoules. So if I divide this by 1,000, I'm going to shorten it so it only includes 3 significant figures, because all of the values up here in the problem have 3 significant figures. This will be my final answer, so it's going to be 11.0 kilojoules of potential energy. Let's look at one more example to make sure we've got this. So here's our second example, and this says a mass of a loonie is 6.25 grams. Now, if you're not from Canada or familiar with Canadian currency, a loonie is a dollar in Canada. That's what it looks like. And if the loonie was placed on top of the CN Tower, this is a picture of the CN Tower. It's the tallest structure in Canada. It's in Toronto, Ontario. It's going to have 34 joules of gravitational potential energy, and it's asking us to solve for how tall the CN Tower is. In other words, we're solving for the height if we're given the gravitational potential energy and up here the mass. And so I'm going to start off with that equation. Gravitational potential energy is equal to mgh, and I'm solving for h, so I'm going to divide both sides by mass and gravity, because that's going to cancel the mass gravity there, and that's going to change this to gravitational potential energies equal over mass times gravity is equal to h. Now I can start plugging in these numbers, but what I want to be careful of is this is given to me in grams, and I have to make sure that's in kilograms. So I'm going to have to convert that. To do that conversion, we can divide that by 1,000, and we end up with 0.00627 kilograms. All right, now I can go ahead and plug all of this in. So we have the gravitational potential energy of 34 joules. We'll divide that by the mass in kilograms, which is what we just calculated. And then we'll multiply that on the bottom there by g, the acceleration due to gravity, which is 9.81 meters per second squared. And if we plug this into our calculator, we're going to end up with a height of about 553 meters. Thanks for watching. In this video, we defined gravitational potential energy, we learned the equation to calculate gravitational potential energy, and we learned how to solve problems using that equation. You can support the Science Classroom by subscribing to this channel and liking this video. You can also support us on Patreon by clicking the link in the description or in the video.